record, but I'm the worst. Atlas, Masha even reminded me, and then I was slow.
No, you said, why are you bossing me around?
Well, I was snarky at Masha for bossing me around, but she was right, and I was wrong. Sorry, Atlas, but I think you're probably good so far from what's written on the page. Right? They all agree that you're probably good with understanding what's going on. Yeah. And then, you guys, what was the midpoint formula? This is going way back to geometry. It's been a while. How do you find the midpoint between two coordinates?
Add and divide by 2 or something.
You're essentially finding the average. Oh, I don't know why I didn't do an add for that last one. Okay, so one of the things in terms of working like within space, one of the things I might ask you to do is find the distance between 2 points or the midpoint between 2 points. So if I give you, say, if I give you these 2 points, could you find the distance between the two of them? So first you would subtract your x coordinates and square it. Then you would subtract your y coordinates and square it. Then you would subtract your z coordinates and square it. Are we feeling good so far? And I think I ended up with the square root of 1 plus 16 plus 25, which is the square root of 42. Does that sound about right? No, that's a 64, but I made that mistake both in my packet and 90? Does 90 sound better? I feel better with 90.
Yes, 90 better.
Man. All right. Now, you guys, do you remember that to find the standard of equation of a circle, we do x minus h, the quantity squared, plus y minus k, the quantity squared. Okay? And that was equal to r squared. Okay? Well, what's going to happen is then we're going to do, and I don't know what the actual letter we use. I'm going to use M, because I don't want to use J for obvious reasons of what we're doing next. Okay, so this is the equation of a sphere, yeah, because it would be a circle in any given direction. Is that okay? And the center of that sphere would be HKM. So if we kind of think through, we're in a sphere, we have multiple, we're in 3 dimensions, right? But at any given 2 points, like if they're a diameter, the distance between those 2 points, like the midpoint between 2 points that are on the diameter would be the center. Just like in a circle, right? If I had, so the sphere looks like this, yeah? let's say at a point here and here, and those are on the diameter, it would have to go through the center of the circle. Are we comfortable with that idea? Okay. And in fact, the center would be the midpoint, yes? All right. So, if I asked you guys what is the center of the circle that has a diameter with these two endpoints, how could we find the center of the sphere? Yeah, you're just finding the midpoint between these 2 points. So, if I ask you guys, what is the center, can you find it for me, please? And you guys, I got 5/2, 1, and 0. Is everybody good? All right. Now, there's a lot of ways we could find the radius to find this thing. What I would probably do is, so I now know it's like x minus 5/2 squared plus y minus 1, the quantity squared, plus z squared, because there's 0, has to equal my radius squared. Is everybody with me? And then what I could do is that's true for every single point that's on this like boundary of the sphere. Well, that means it's got to be true for either this point or this point. We can pick which one we want to do and just plug it in for those x, y's, and z's, and we'd only have one variable left. So, for example, I might do 5 minus 5/2 squared plus -2 minus 1 squared plus 3 squared equals the radius squared. Does that make sense?
I'm gonna say that I tried, but yeah.
Well, you're not supposed to be fully ready for it. Just put it on the far left. Thank you.
You're welcome. All right.
And did you guys get, what are you guys getting for this? I just didn't feel like typing it into my calculator. So I turned the 9s into 36/4. Are we good? And let's see. So that makes my final equation of the sphere x minus 5/2 squared plus y minus 1 squared plus z squared equals 97/4. Feeling good so far about 3D space? Oh, here's a good one.
Sketch the sphere.
Yeah. So let's start with, don't worry about sketching the sphere yet. Let's go ahead and just find the center and the radius. Hopefully you guys are feeling pretty comfortable with completing the square. So I might rearrange this into x squared minus 2x, I'm going to leave some space, and then y squared plus 6y, I'm going to leave some space, and then z squared plus 8z, I'm going to leave some space, and then I'm just going to put a -1 on the other side. Okay, so if I complete the square for the x's, so only here, what do I need to add?
-1.
+1, because when you square it becomes positive.
Oh, yeah, yeah.
And the result will be x minus 1, the quantity
Yeah.
squared. Okay, and so I'm going to, so since I added a +1 on the left, I'm going to add a +1 on the right. All right, what about for the y's? We would need a 9. And if I add 9, guys, what does that factor out to? What's being squared?
Oh, yeah.
Y plus 3, okay. And then, what do the z's need?
16.
And so we have z plus 4, the quantity squared, equals 25, I think, yeah? Okay, so if I asked you guys, what is the center of our sphere? What would you say?
-1, 3, 4.
1, -3, -4.
Yeah.
All right, so guys, if I tried to graph that, here's 1 on the x-axis. Here's -3 on the y-axis. And -4 on the z-axis. So it would have to be the equivalent of this point drop down to here. Ish. Are we okay? So it corresponds to this point, and this point is the idea. And then a radius of 5. I go 5 in one direction and then scooch it around. Don't stress about the sketching of the sphere, as long as you're close. If you had it up here, I would have a problem with it. You guys get what I'm saying? Because we don't really have quadrants anymore, we have octants. All right. Now, just like we can plot points in 3D space, we can plot vectors in 3D space. So we still have I, which used to be 1, 0. Now it's 1, 0, 0 because it's only going one unit in the positive x direction. Okay? Which would be the equivalent of this vector. It's like orange vector I drew in here. Is that okay?
There's 2 Ks.
I'm sorry?
There's 2 Ks now.
Yeah, they're not the same K though. All right. J is going to still have the second component being 1 in the y direction. So that would be the equivalent of this vector. So this one's I, this one's K. I'm sorry, J. And then and essentially what this table is basically saying is almost everything that applied in 2-dimensional vectors will apply in 3-dimensional vectors. Okay? So, for example, if I want to find the component form, I'm now going to have 3 components instead of 2, 1 in each direction. So, you guys, what is the component for the first descriptor of our vectors? So we're going from -2 to +0. Or to 0. There's no +0. So what's that first direction going to be?
2.
+2. What's the second one going to be? Going from 3 to -4.
So,
Going down by 7. Okay. And then going from 1 to 4. 3. So now if I asked you guys to put this in, to turn this vector, so by the way, this is vector v. If we wanted to turn this into a unit vector, so right now its length is not 1, but if we wanted to make it 1, we could. And so what would we need to do in order to turn this into a unit vector? We'd have to divide through by its magnitude, which means we have to find its magnitude, which will be the square root of, well, it used to be 2 squared plus -7 squared. That's what the last section showed us. And now with the third component, we have another square. Guys, I ended up with the square root of 62. But last time I found one by hand, I think I got it wrong, so you guys should double check me for sure. So the unit vector would be 2 over square root 62. -7 over the square root of 62, and 3 over the square root of 62. If you wanted to, you could call that 2 root 62i.
Wait, so why do we put it over the square root again?
So if we're finding that vector's unit vector, the total length of the vector needs to be 1 unit.
Oh, okay.
So we could also write this as 7, like in that linear combination form. And those two things are equivalent.
Do we need to write one of them, or like which one would you rather?
I would imagine the way I will word it is that I'll give you a choice. You need one or the other but I could also not give you a choice and be like, put it in component form, find the component form, find the linear combination form. So you should be familiar with both. But I think knowing one and knowing the other are pretty self-explanatory. Are we feeling good? Cool. Now, two vectors are considered to be parallel so like vector u be parallel to vector v if I can take u and it's equal to some scalar number times v. So always the same number. Okay? So, for example, if I look at just u and v here, what would I need to do to the 3 to turn it into the 12? What would I need to multiply it by? 4. So if I do 4 times vector u, if I want to decide is it parallel to v, well, let's do 4 times vector u. I would get 12, negative 16, and negative 4. So does that match? That means u is not parallel to v. You guys see anything else that might be parallel? W and U. And if I asked you to prove that?
You can multiply well, if you're doing W, you can multiply by negative 1 time.
Okay, so if I do negative 1/2 times vector W, I get 3, 4, negative 4, and negative 1. That is equal to U. So we're good.
Yeah, no, I don't think W and V are parallel.
Well, if W is parallel to U and U and V are not parallel, does this make sense? Cool. I'm done with notes for today. You guys have about 20 minutes.